Thanks, guys, for joining us today. It's really appreciated. As Kerry said, we were really busy this morning, so it's proving that there's quite a lot of interest from our distributors in finding out about this new technology, what we're bringing out new, and I guess exciting is that these products are novel. No one else has anything like it, so you can keep your margins. You're not up against competition. And it gets you, in front of customers, able to talk to them about something new, different. And if you accidentally sell some other equipment at the same time, then all well and good. But it's but continuously bringing out new products, we're finding it really helps our sales of all product lines, and it's a critical aspect of our business. Anyway, I'm going to start a presentation. And then we'll go through that bit by slide by slide, and then come on to the equipment behind me here. So, it's the computer. Just to say, if with Zoom, it may put pictures of the videos inputs from individuals over the text. You can move that around. I think there's a way of doubling it, isn't there, Aaron?
Yep. So if you just go view on the top right and do side-by-side speaker or side-by-side gallery, that's going to be the nice view with mainly the presentation, but a small strip on the side for us.
Okay, so we can send you a copy of the presentation at the end, which may help. But whoops, okay, didn't need to do that. So photochemistry is chemistry using light, photons, and just like nature does perform photosynthesis in a plant from sunlight, then many chemistries are being proven to react really well with light. Now, photochemistry is not a new thing, but it's a trend. It's there are new catalysts that react to certain light frequencies, for instance, 450 nanometers, which is a popular one, and also to 365 nanometers, ultraviolet. So blue and ultraviolet are very popular. But other wavelengths of light as well, including white light, just high power, intense white light. Some of our customers are looking at too. So it's a trend, and it allows, as it says at the bottom of this slide, the customer, it allows them alternative reaction pathways. So I visited AstraZeneca yesterday. They're trialing a new product design that I'll give you a glimpse of at the end of this presentation, what we're developing. They're testing some real-world chemistry with that product, which is really exciting to have one of the world's key pharmaceutical companies looking at it. But what they were telling me is, these photochemistry is really quite important for them to look at, to find those novel new drugs and pathways. So it's something that's quite exciting. So photoreactors are generally devices that shine a light into a glass tube or receptacle. The light wavelengths are very narrow, and actually should be, in many cases, like the UV and the 450 nanometer blue, are quite dangerous for people's eyes. So shielding from that light is quite important. But having said that, many customers have homemade solutions at the bottom of this slide, meaning they've made things themselves using some lights around a flask or something. But the shielding, the safety is not ideal. So considering that the safety is becoming more and more prevalent, certainly in the UK and many of our customers we visit, I think really these homemade solutions are going to be, not really looked at very well. So scientists should be looking for safe and reproducible devices. Some of the competition, I said there's no competition for our products, and in fact, it's probably the case that there is a slight competition, is that other manufacturers make photoreactors to perform chemistry. But these generally have big flaws and issues. For instance, the product number 2 is simply a circular strip of LED shining up some tubes.
Zooming.
Oh, someone's got their thing.
The supplier.
I mean, what we're reading? So
It's bigger at 5. Now I put off the video.
You do, everyone, Aaron. Apart from me, thanks. So number 2 is a circular device, but it has high intensity LEDs. It's pretty much homemade, but Sigma Aldrich sell this for a lot of money, for something that you could probably make for just a very small amount in your garden shed. So not ideal. The reactor pictured number 3 is a very sophisticated looking device. It looks smart in the fume hood. It has a nice touch interface. It's quite expensive, but when you look at how it works, it simply has a low power single LED that shines at the bottom of a reactor tube. So it's a bit like holding a torch, a simple low-cost torch on a reactor tube with a nice enclosure. So again, not high performance in any way whatsoever. Many issues with the no ability to control inert atmosphere, which is quite critical for many photochemical experiments. One we've seen in a few labs is number 5, Hepatochem. This has a high intensity light that simply shines off a mirror and reflects that light onto an array of tubes. The problem is, again, safety, light leakage, but also considering this is a screening device, the amount of light that gets to each tube is different. So therefore, the intensity of light for each of those individual experiments is not consistent. And it's pretty much homemade by a 3D printer. So it's a very expensive piece of 3D printing. So in the usual Asynt style, we wanted to keep things really simple, but to the highest quality of manufacturing, and keeping them simple, but not necessarily not sophisticated, having the key aspects of sophistication included. So a product we've had for a little while now, we call Illuminate, and it's based on our Opto parallel reactor with 8 positions. That's a product that's been very successful for several years now. We're growing sales more, year on year of this product quite extensively, with customers who purchase one and then want many more for other fume hoods. So it's the ideal screening tool. And by talking to customers, looking at photoreactor designs, it was apparent that the simplest thing to do would be to take the tried and tested design of the Dry-Syn Opto and adapt it to be a photoreactor. Quite simple indeed. So we'll go on to a little bit of a specification, and we'll look at the unit itself. So parallel photochemistry. So for screening multiple reactions, up to 8 at a time. We have multiple different colors available, and it's a user interchangeable light source inside. Customers can heat up to 80 degrees centigrade. And everything's cooled with a built-in cooling fan. But we also have an effective cooling option for very stable temperature control at 20 degrees or below, or even subambient. That's now available. So it's just a simple on-off device, and I'll stop sharing the screen now, and we'll get close to the illuminate.
This is spotlighted, so if everyone just clicks on speaker view, and it goes big screen.
Okay, thanks, Aaron. So I won't go into dry-syn opto in any degree today, but we can certainly come back to this. If you haven't had any success in selling these, then please talk to us. We can go through why this is such a successful growing tool for our business. Again, the only competition really against us is 4 or 5 times more expensive. So this is a great tool for the laboratory for screening reactions. So heating and stirring, 8 reaction tubes. We use a low-cost reaction tube in this version, complete inert atmosphere control, with the ability to sample or make additions under inert atmosphere through these septums. These are standard auto-sampler vial caps, so it's very low-cost consumables for your customer. We have a shorter version. The shorter version just allows for a small tube, in respect that allows additions to be, or sorry, samples to be made with a standard length syringe. So that's a reason for that. So we took this shorter version and then developed the photoreactor module. So as you can see here, the tubes are in a heating cooling base, but this has cutaways. So each tube is completely open to high power, high intensity LEDs around the outside. So each one of these has a 10-watt high power LED very close to it. If I lift up the unit, this is the the lighting ring. You can maybe be able to see the LEDs inside here. These have a shield. There's a borosilicate glass shield, so the electronics is kept away from the reactor tubes themselves. It sits on the standard magnetic contact stirrer, and then you quite simply drop the illuminate in place. Again, because of the inert atmosphere control, and because we have an individual LED for each reactor tube, your customers will get perfectly even illumination of each reactor and that gas control. So if I turn it on, one of the key safety features is you may be able to hear the fan running. So the cooling fan's working, but the lights are not on. Drop the illuminating base. I've got it back to front. Yes, I have. There we go. Deliberate. So we have, I should show you, there's a pin here that only allows it to fit in one way. There we go. So as it tightens down, it will activate a micro switch and the lights turn on, which you can see. There's a temperature probe hole here, so you can control and measure the temperature of the block that the tubes are sitting in. So it's quite safe. It's a little bit of light coming through is just enough to see that it's working, but totally safe for the user in the laboratory. So no other shielding needed around this in any way whatsoever. So before we move on, does anyone have any questions so far, please?
We did have one question, but it's been answered. But I think if everyone can just see it, Bharat's asked if a user can change the wavelength themselves, which is a really good question. And one of the key features of this is that any user can change the wavelength themselves. We supply the other ring, light ring, in whichever wavelength. And there's a video, a YouTube video, which I put in the chat. It's not on our official channel. It's kind of a technical video, but the link is there, and it only will take the user less than 5 minutes to change modules. And there's no complicated tools or procedures or electronics knowledge you need. It's super simple.
Great. Right, we'll move on to back to the presentation. So again, low-cost consumables, really quite important for customers. Many products out there deliberately design consumables that are unique to them and very expensive. So the septums, tubes, etc., are all low-cost stirring bars for our customers. So this should, keep them very happy, but not a lot of money for a long time. So I'll move on now to our newest product in terms of photochemistry, Asynt Lighthouse. And this is a unique way of getting as many photons as possible into a reactor vessel. Again, we have it's either parallel or single position, but they're the same device, which I'll show you in a moment how that works. We say heating up to 80 degrees centigrade. That's because we haven't tested it beyond that temperature. I think actually it'll probably go to much higher temperatures safely. The key thing is the electronics are a long way away from the heating of the tube, and I think we could probably go to higher temperatures. So we'll be testing that in the near future. Some of our customers, for instance, AstraZeneca, they perform some of their photochemistry at around 50 degrees centigrade. Why they do that is because they're doing dual reactions where they have a photocatalysis that's being activated by the photons, and they've got a secondary reaction at the same time, which may be palladium coupling, that needs around 50, maybe 60 degrees centigrade to activate. So in some cases, heating will be needed. Much of photochemistry, if it's photochemistry only, no other reactions happening at the same time, then often room temperature is needed. All of our devices have cooling options, so subambient or absolutely guaranteeing that the temperature is at, say, room temperature 20 degrees centigrade for a long period of time. That is all possible. So it's up to the customer how critical they think that aspect is. So what's unique about this is the way we bring the light in from the lamp at the top of the reactor. We shine the LEDs directly into a quartz rod, And I think the best thing is if I show you that on the bench here. So let's move the camera. Turn this off. So with the lighthouse, we have a single position base. Then we have a 3-position base. So you can mount 3 of these onto that one base, hence how the photograph looks. If we simply lift off the top of the reactor, you can see what we've got. We've got a reactor tube. Inside we have a quartz rod. This is what brings the light down, but then escapes of this tapered end directly into the reaction medium. The working volume of these tubes is, we think, around 18 to 20 milliliters maximum, so it gives quite a good step up in process scale. How it all works will be revealed in a moment. Here we have the photo module itself. It's a very high power 10 watt LED here. This is controlled and cooled directly by a fan inside the housing. So this does not get hot. It gets warm but not hot. So the electronics are kept well below their safety limit. This section is made of carbon-filled PTFE. So chemically resistant but quite hard. It's also a good insulator. This is why I'm thinking that really we can go beyond 100 degrees or 80 degrees certainly, because this will insulate the electronics from any heat down here. We have a simple tube arrangement using a GL32 thread. So a very simple tube. And here is the quartz rod. Quartz rod is easily removed for cleaning or replacement. It's a very simple fitment, just a hand tight and it's held in place. To change different light wavelengths, you just simply swap out the top. So the customer can have, if they only want one lighthouse, but they want to have different colours, they can just buy this top unit with the different wavelengths. What we have to power the unit is very simple. It's a readily commercially available 24-volt power supply. It's pretty much the same as the power as the average laptop computer. So I turn it on. If we plug in, no light, as you can see. But you might be able to hear the fan working. So the fan's keeping the electronics cool from straight turning on. Once you put this in place, the micro switch inside activates and the light is turned on. We have 2 ports here. These are for feeding in a capillary tube, for making additions or taking samples during operation. And on the side, we have a gas tube for making inert atmosphere, argon, nitrogen. It's a very, very simple device. And it's safe to use, goes in a standard hot plate stirrer. And we're developing some larger versions that I will show you, also not so much versions, larger options with the same light unit that I'll show you shortly. So again, any questions at this stage, please?
Yes, Marty, I have a question. You mentioned that with the photoreactions take place because of the light energy that's used to heat. So does the heating have to come through the hot plate, or is it just light energy that used?
So maybe I confused things a little bit. The photons are exciting. I'm not a chemist. Kerry and Aaron maybe can explain. The photons will excite the catalytic materials and get those reactions occurring. Traditionally, most reactions are performed just by heating. You add energy through heat, which makes the atoms vibrate and they all start to react together. With photochemistry, it's very much the photons, not heating. Now, a lot of photon energy could warm the sample over time. The magnetic stirrer, just the magnetic drive, will warm the sample over time. So magnetic stirrers normally will reach about 30 degrees centigrade just from stirring something over
in the UK.
Sorry, Aaron?
In the UK, maybe not on a hot day in California.
Yeah, even hotter. So hence why we have the cooling options for customers who want to ensure exactly 20 degrees centigrade or minus 10 or something. Not a problem at all.
I think the issue really comes down to is reproducibility. So chemists want a reaction to be able to work again and again, to be able to prove it so they can publish on it. And if something is heating an unknown amount, it's not good. It's going to skew your results. So the challenge in photochemistry and why, these solutions are better than homemade solutions is because we know we can extract some of that heat, which we don't want to go into our sample unless the chemist explicitly does want to heat it using the hot plate. The chemist doesn't want any of the electronics or the photons to heat it. The photons are a different source of energy to heat energy, thermal energy.
If you look in the chat as well, guys, I've been putting links and things to different application notes. As you all know, and I can say this myself being a chemist, we can be difficult people and we always want evidence of what happens with reactions and what products work well. And so I guess you find with all the other Asynt products, people want evidence that something will do what we say it does on the tin. So there's a whole load of application notes and white papers and technical detail that I've been putting down the side. So these are really good tools to use with your customers. There's a few YouTube videos on there as well. And as Martin goes through the presentation, I'll keep putting those links to application notes, white papers, YouTube videos, and all of these are really helpful for you guys when you're talking to your customers. Please feel free just to utilize them, or if you need anything else with regards to that kind of detail, just let us know and we'll do all we can to help.
Will that be available after the meeting, the links?
Yes, they should still be in the Zoom thing, but Aaron can absolutely
so I'll send through a copy of the chat afterwards, which will have those links in. But yeah, the lighthouse as a kind of USP is this technology where the lamp source and therefore the heat is a long way away from your sample. So this is a really unique concept which no one else is doing.
I have a question, please.
Yeah, of course.
Martin, you have shown us 3 openings that will allow us to introduce a gas and to take out a sample or introduce a substance, but where does it go? I didn't see any tube going into the glass tube.
That's because we don't have any tubes on this one. So you just simply connect the capillary tube, like a chromatography fitting, and then you can run a tube to the bottom of the reactor.
So I need to have something in open tube like 116 or something like this?
Yes, exactly.
Exactly. But I believe it comes with that that option. It comes with the tubing, or they're an accessory, so you don't have to provide it yourself. It's just for the purposes of this demonstration. The one with the tubes that we had has gone to a customer yesterday. So well spotted. But yes, when you receive one of these, it will have the tubes for addition sampling.
And then
Also,
also,
we'll have lure fittings as well for the customers. They can connect their syringe directly to make that addition or take sample.
okay, and for steering, we're using a simple magnetic bar.
Yes.
Okay,
Exactly.
thank you.
Okay, we'll move on. Okay, so moving on now to the reactor. But it's the photo module for reactor. So some of you may be familiar, we've talked before about our reactor developed by the University of Leeds, which is a really simple entry point into performing flow chemistry. So flow chemistry, like photochemistry, they're both very trendy, growing areas of science in the chemistry laboratories we visit. A lot of flow chemistry equipment is very expensive and very sophisticated. Our sister company is one such company. However, what we have with the reactor is a low-cost entry point into performing flow chemistry. It is sophisticated in what it can achieve, but it doesn't have any automation, no electronics. We've been, like I say, we've talked about that before. We're more than happy to spend more time with you guys going through the flow chemistry aspect. But today I want to really talk about how we add a light source onto the reactor. We allow heating again up to 55 degrees centigrade, and the customer can put up to 5 photo modules onto the reactor. And depending on customers and the orders we've received, you don't have to buy 5, you can just buy 1 or 2, however many one thinks is necessary, or different colored units. So I'll go on now and actually we'll look at the product for real. Move the camera again. So here we have the reactor. There's 2 here. Different reactors in place. And this is one of the light modules. So as you may be familiar, the reactor is a continuous stirred tank reactor for flow chemistry. So you've got basically 5 reactors, each with a stirring bar, a little window, ability to heat and stir with the hot plate stirrer. And then you simply pump around. You can plumb it as you wish, or as the customer wishes, for that scale up, or whatever they may want to do in flow chemistry. Because they have windows on the top, it made sense to be able to add a light source to allow a continuous flow photoreactor option. So we work with Leeds to develop these. Now, it is actually the same technology as the lighthouse. There's the electronics, the mechanism, etc., is identical inside here. So we use the same electronics, the same cooling, the same LEDs. Instead of the rod, as in the lighthouse, there is a lens. So that lens focuses the light and aims it directly into the window of the reactor. So the light gets focused directly into that reactor itself. So you've got 10 watt high intensity LED focusing all of its energy directly into the the reactor itself. So they use, again, the same power supply. So it's a simple case of plugging it in. The fan comes on, the light doesn't. It's a micro switch. But once it's on top of the reactor, it activates. There isn't a window to see it's in operation, but normally there's a little bit of light you can see coming out, so you know it's in operation. So, as Kerry was saying earlier, we've got several pieces from the University of Leeds showing how this performs effectively in flow on the reactor. This is just one unit, but it's very simple to add multiples. You only need the one power supply. We've got splitter cables like this one. This one does up to 4. We have the ability to put up to 5 on here at a time. Popular purchases would be just 1, or 2 of, or even 5 of. Some customers have bought different colours. So they've bought a blue one, a 365 nanometer UV, or 2 of each, and it gives a really good throughput. And again, it's something that's modular and customers can build upon over time. So it's a simple, very simple device, just on and off, nothing really to go wrong, and it's going to offer your customers a continuous flow photoreactor at a reasonable entry point in terms of cost. Now, customers may say that they already have a flow chemistry system. For instance, like our sister company or one of the big companies out there like Vaportech. But their photo system add-on is around, we hear, about £20,000. Well, for a fraction of that cost, you could buy a reactor and actually use it with the Vaportech. It'd be much cheaper way of getting into photochemistry or photoflow chemistry, for an example. So this is showing it working on the smaller 1.8 milliliter reactor. We have a bigger 7.5 milliliter, 8 milliliter reactors. It will work with those just as well. So the ability to scale up too. Okay, so we'll go back to the slides. So a wide range of wavelengths, just as all of our products. Common, the 365, 450 nanometer. They're the ones we manufacture and keep in stock. But other wavelengths can be fabricated to custom orders. It's just a case of a different LED, which we also hold quite a few in stock. So we've been through that. It says here, compatible with snowstorms, cooling base. So again, that's possible to cool it with what we already have. We're also shortly offering a cooling base or cooling version of the reactor. So of course it will work with that too. So not a problem. But realistically, not a lot of heat from the electronics gets to the reaction anyway. So not really a big problem with heat buildup with these products. Okay, does anyone have any questions on the reactor at this stage, please?
Yes, please. What are the flow ranges?
It's sort of flow ranges that people might use, where it would work out their how long they want the resonance time to be in terms of minutes, hours, or seconds, and then calculate the flow rate. So sort of pumps that people have been using with these are are often of a maximum flow of around 10 milliliters a minute. But quite commonly, they might run at half a milliliter a minute, or lower volumes, depending on the reaction time. So the customer would just need to work out how long they want the residence time, for the materials to be in the reactors.
Okay, and the volumes of the flow cell itself?
Each one, if I remember rightly, 1.8 milliliters is the standard size.
Okay, and maybe last question, maybe I missed it. What's the difference between the peak inlet and the PTFE inlet?
Between the peak and the PTFE, you say?
Yes. Between the brown and white.
One is just a stopper. So one is a blanking off cap, and one you actually put the tubing through. But you can obviously change the blanked one to something from maybe a temperature probe or another feed in if you like.
Let's just grab one. So this one, well, this is a Hastelloy one. Each reactor has 4 ports. So we provide 2 blanking plugs normally with the kit, and then 2 ports that you can use.
So the white PTFE ones are blanking, and the peak ones are for the tubing.
But a customer may want to have 2 feeds into here, or they may want to put a thermocouple in to measure the temperature of the solution inside. So there's many options a customer can do by having the 4 ports.
Okay, thank you.
And yeah, myself and Anthony will both put the website in the chat where you can work out residence times and flow rates, which is really useful for kind of traditional chemists who know about batch processes in flasks. They can easily use this website and transfer what they're doing to the flow, or calculate how they would do it flow. Martin, you're on mute.
Sorry, we're happy to go through any. I forgot I muted myself. We're happy to go through any time on a one-to-one basis any of our products. So a bit more detail on the flow reactors, photoreactors, or any of our products. Please let us know what you'd like to go through, and we can spend time and go through all the features, benefits. Why does something sell? Why, what makes us different to other companies out there? So let's see if we can get the slide to change. Okay, so the final slide is where the lighthouse is going and we're developing. So at the moment, as of yesterday, AstraZeneca are testing a prototype out for us. So it's using exactly the same lighthouse, electronics, and rod, but with the ability to go upscale with round bottom flasks. In this picture, the engineering design shows a 500 milliliter round bottom flask. It's still very small footprint, no bigger than a hot plate stirrer. A safety shield, so no light escaping. But the ability to use any dry syn insert you may be familiar with by looking at the bottom there. This is a 500 milliliter dry syn multi-insert. So any of those multi-inserts could be used. It's probably going to be popular, we think, for 100 milliliter and 250 milliliter round bottom flasks. With that immediate scale up, a little bit more material that many medicinal chemistry laboratories, research laboratories require. And they need those sort of volumes before it gets to the process development guys. So it's not, it may be that to scale photochemistry is better to go into flow, but I think many customers we're coming across initially just want to prove the chemistry at a slightly bigger scale in a round bottom flask. And this is where Lighthouse, we believe, is going to be very effective. So the real chemistry is being done now, and in about 2-3 weeks' time, that trial with AstraZeneca completes, and we'll be able to compare the performance with other products that they've tested in the past. Quite a few of the reactions they've been doing when they go to these larger scales can take 3 days. So if we can reduce that time down from 3 days to 1 day or less, then they'll be very, very happy. But we'll see how it performs. So that's it for the presentation. Here.
And any other questions? I just want to obviously emphasize that although you'll have a copy of this webinar, if it does come to any one-on-one meetings with the end user, we're very happy for you to just contact me, and we can arrange a day and a time and use this demo suite facility so we can do any video calls joint with your customer so they can see it hands-on, well, as close as hands-on will be. So just let us know. That's obviously always on the table, not just for these products, but for anything.
And we're also going to be doing, sorry Martin, we're also going to be doing regular training for the distributors. This is going to be happening on a monthly basis going forward. So the next meeting, I'm sure Aaron and Anthony will be in contact with you guys. Nicolene, I'll be in contact with you, is on the 22nd of November, and it's going to be on the condensing waterless condensers. So we want to be here to help you. We want to be here to support you. We've got the whole fabulous, exciting new demo suite behind Martin and all around Martin. So we've got literally, or you guys have got everything at your fingertips with regards to all the Asynt products. So please use us, please utilize us, please, any help, anything that you guys want, we'll jump on a Teams call and help you with everything. So the next one will be the 22nd of November. It'll be on the condensing. But if there's anything that you guys want to know more about, let Aaron, Anthony, myself know, and then we can book that in for like a demo session and a training session for you guys as well. So keep us in the loop, keep us informed, and we want to help you as much as we can.
Can I see the cooling block that's on the left, Martin? That you showed us briefly during the one. I thought you had a unit that accepts liquid nitrogen for cooling. Is that accurate, or is it only chillers that connect for temperature?
Not yet. So the lowest we've gone down to is -80.
Oh, it's -80, but that's used for battery, like these.
Yeah, test beds or to keep things like cryo storage. That type of thing.
Okay, yeah, because we have one of the pioneers in the battery research in Dalhousie.
Okay.
Who
so anything which rapid heating, cooling, yeah, -80 is very impressive that we've managed to get down to. Nothing further yet.
This is a -70 device. This links to a Ulavo. -90 device, but this will go to -80 with no ice formation on the outside.
Yeah, but I couldn't find, and maybe I wasn't looking in the right place, but on the website I couldn't find the big one that's with the 6 blocks.
Not up there yet. It will be going up quite soon. Pictures of that one. I'm not quite sure why it's not up yet.
This was designed for
a very specific customer and application.
It's custom built for biological samples.
Yeah.
Base. But this could be a battery.
So that keeps microplates at 96 well plates at -80.
This has been
-80. Okay.
and it is effective at -80 with no issue. So we worked with Yolabo on the internal cooling technology to make it as efficient as possible. I can't remember, what was the cool down time, Aaron, with the Yolabo?
90 minutes or so.
90 minutes to -80. Okay. So yeah, good.
Okay.
Thank you very much.
Thank you. Something just to mention really briefly. Reactivate here, datum. We're working on a photochemistry concept to allow chemists who are working, say, the 1 liter to 5 liter scale to perform photochemistry. So whether it will work effectively, we're going to find some very friendly customers to test it for us. But if it does, it could represent a really exciting, sensible and safe way of scaling photochemistry using an existing datum or similar reactor. But that's a development we're working on. Probably be 6 months before we have it ready to show you.
And I think just hopefully one take-home message from today is that any potential customer for photochemistry, we should have a solution for, because we cover a huge range from very small scale up to getting to be quite large, even though that's still in development. Just kind of talk to us. We'll make sure that your customer gets the right advice or and right product for them. We've got kind of everything covered from the R&D, just looking to screen something, to potentially a little bit of scale up, going a bit bigger. We've got it covered with safe, reproducible, accurate, off-the-shelf reactant systems.
Great. Any other questions from anybody? If not, thank you ever so much for joining us today.